A Y connection is a three-port connection that resembles the letter Y. Y connections are primarily used to split a fluid flow into two streams or to merge two streams into one. Applications for Y connections include industrial piping, plumbing and heating, ventilation and air conditioning systems. A delta connection, however, is not a specific connection type in plumbing or piping. Delta connections typically refer to electrical connections, where the 3 points of a delta are connected to 3 wires. Electrical applications of delta connections include configuring electrical motors or transformers for certain operating conditions, especially in three-phase power systems. The key difference between Y and delta connections lies in their shape and purpose. A Y is a three-port connection used for fluid flow splitting or merging, while a delta is a three-point electrical connection. Y connections find their applications in piping systems, while delta connections are used in electrical systems. In more detail, let's explore Y connections firstly. These connections are crucial in scenarios where a single flow needs to be divided into two separate paths or where two flows need to converge into a single outlet. In industrial piping, Y fittings are commonly employed in distribution networks to regulate the flow of liquids or gases to different parts of a facility. For example, in a chemical plant, a Y fitting might be used to split a stream of coolant to two different reactors, ensuring each reactor receives the necessary cooling to prevent overheating. Secondly, in plumbing systems, Y connections play a vital role in drainage systems. They are often used to connect two branch drain lines into a main drain line, allowing wastewater from multiple fixtures to flow into a single discharge pipe. This configuration is preferred over other types of connections, such as T-fittings, because the gradual angle of the Y minimizes the risk of clogs and backflow, ensuring efficient drainage. Thirdly, in heating, ventilation, and air conditioning systems, Y connections are employed to distribute airflow to different zones or rooms within a building. For instance, in a multi-zone HVAC system, a Y duct fitting might be used to split the main supply duct into two or more branch ducts, each serving a separate zone with its own temperature control. This allows for customized climate control in different areas of the building, improving comfort and energy efficiency. On the other hand, delta connections are exclusively used in electrical systems, particularly in three-phase power distribution. In a delta connection, the three phases of an alternating current power source are connected in a closed loop, forming a triangular shape, which gives it the name delta. Unlike a Y connection, a delta connection does not have a neutral point, which means it cannot provide a direct single-phase voltage. Delta connections are often used in applications where a high starting torque is required, such as in large industrial motors. One common application of delta connections is in power transformers. Transformers are used to step up or step down voltage levels to match the requirements of different electrical equipment and distribution networks. In a delta-connected transformer, the primary and secondary windings are both connected in a delta configuration. This configuration is advantageous because it provides a balanced three-phase output and can handle nonlinear loads more effectively than other connection types. Another application of delta connections is in motor control circuits. Large industrial motors often use a delta star or star delta starting method to reduce the inrush current during startup. In this method, the motor is initially connected in a star configuration, which reduces the voltage applied to the motor windings and lowers the starting current. Once the motor reaches a certain speed, it is switched to a delta configuration, which applies the full voltage to the windings and allows the motor to operate at its rated power. To further illustrate the differences, let's consider a specific example of a Y connection in a residential plumbing system. Imagine a scenario where a homeowner wants to install a new bathroom sink in an existing bathroom. To connect the drain line from the new sink to the main drain line, a plumber would typically use a Y fitting. The Y fitting would be inserted into the main drain line, and the drain line from the new sink would be connected to one of the branches of the Y. This allows the wastewater from the sink to flow smoothly into the main drain line without causing any obstructions or backflow. Now let's consider a specific example of a delta connection in an industrial power distribution system. Imagine a large manufacturing plant that requires a significant amount of electrical power to operate its machinery and equipment. The plant receives its power from a utility company through a three-phase delta-connected transformer. The transformer steps down the high-voltage power from the utility grid to a lower voltage that can be used by the plant's equipment. The delta connection ensures that the plant receives a balanced three-phase power supply, which is essential for the efficient operation of its motors, pumps, and other electrical loads. In summary, Y connections are used for fluid flow applications, such as splitting or merging fluid streams in piping, plumbing, and heating, ventilation, and air conditioning systems. Delta connections, on the other hand, are used for electrical applications, such as configuring motors and transformers in three-phase power systems. Understanding the differences between Y and delta connections is essential for anyone working with piping, plumbing, or electrical systems. Firstly, Y connections are predominantly employed in fluid handling systems, where the efficient division or merging of fluid streams is paramount. Their applications span across diverse industries, from chemical processing plants to residential plumbing setups. Secondly, delta connections find their niche in the realm of electrical engineering, particularly in three-phase power distribution systems. They play a critical role in configuring motors, transformers, and other electrical equipment to operate under specific conditions. In terms of specific applications for Y connections, let's delve deeper. One prominent use case is in chemical processing plants, where precise control over fluid flow is essential for maintaining process stability and product quality. Y fittings are strategically placed within the piping network to split a single stream of reactant into multiple streams, each directed towards different reactors or process units. This ensures that each unit receives the required amount of reactant, enabling efficient and controlled chemical reactions. Moreover, Y connections are also widely used in residential plumbing systems, particularly in drainage networks. They facilitate the connection of multiple branch drain lines, such as those from sinks, showers, and toilets, into a main drain line. The gradual angle of the Y fitting minimizes the risk of clogs and backflow, ensuring smooth and uninterrupted wastewater drainage. Moving on to delta connections, their primary application lies in electrical power distribution systems, where they are used to configure transformers and motors for three-phase operation. Transformers are essential components in power grids responsible for stepping up or stepping down voltage levels to match the requirements of different equipment and distribution networks. Delta-connected transformers provide a balanced three-phase output and can effectively handle nonlinear loads, making them ideal for industrial applications where electrical loads can fluctuate significantly. Furthermore, delta connections are also employed in motor control circuits, particularly for large industrial motors. Delta star or star delta starting methods are commonly used to reduce the inrush current during motor startup. By initially connecting the motor in the star configuration, the voltage applied to the motor windings is reduced, thereby limiting the starting current. Once the motor reaches a certain speed, it is switched to delta configuration, allowing it to operate at its rated power. In contrast to Y connections, which are primarily used for fluid handling, delta connections are exclusively used in electrical systems. They do not have any applications in piping, plumbing, or heating, ventilation, and air conditioning systems. This fundamental difference in application underscores the distinct roles that Y and delta connections play in different engineering domains. To further differentiate between Y and delta connections, let's consider their respective advantages and disadvantages. Firstly, Y connections offer the advantage of simplicity and ease of installation. They are relatively inexpensive and can be readily integrated into existing piping networks. However, they may not be suitable for applications where precise flow control is required, as the splitting or merging of fluid streams can be influenced by factors such as pressure and viscosity. Secondly, delta connections provide the advantage of balanced three-phase power distribution and the ability to handle nonlinear loads effectively. However, they do not have a neutral point, which means they cannot provide a direct single-phase voltage. This can be a limitation in applications where both three-phase and single-phase power are required. In summary, understanding the differences between Y and delta connections is crucial for engineers and technicians working with piping, plumbing, electrical, and HVAC systems. Wye connections are ideal for fluid handling applications, while Delta connections are essential for electrical power distribution. By recognizing their respective roles and limitations, professionals can make informed decisions about which type of connection is most appropriate for a given application. To ensure clarity, let's reiterate the key distinctions between Wye and Delta connections. Firstly, Wye connections are three-port connections used for splitting or merging fluid streams, while Delta connections are three-point electrical connections used for configuring motors and transformers. Secondly, Wye connections are primarily used in piping, plumbing, and heating, ventilation, and air conditioning systems, while Delta connections are exclusively used in electrical systems. Thirdly, Wye connections offer simplicity and ease of installation, while Delta connections provide balanced three-phase power distribution. By keeping these distinctions in mind, professionals can confidently navigate the complexities of piping, plumbing, and electrical systems and ensure optimal performance and safety. In conclusion, while both Wye and Delta connections are fundamental components in their respective domains, they serve distinct purposes and are governed by different principles. A thorough understanding of their characteristics and applications is essential for anyone involved in the design, installation, or maintenance of piping, plumbing, and electrical systems.